Hi there, we have a geometry video this time, reminding ourselves of the areas of different two-dimensional shapes. Let's get stuck into it. Write the formula used to find the area of a rectangle. Area of a rectangle, length times breadth. Area of a square, the size of each side squared or times by each other. These are quick reminders here. Write the formula used to find the area of a triangle, half the base times the perpendicular height. Write the formula used for the area of a parallelogram. Area of parallelogram is area of base times height, but we need to measure that height. I'll draw a quick parallelogram here. I'm not known for my neat diagrams, but still. So we have a parallelogram there. We have a base here. And the important bit when we're finding the area here is that we have at our disposal at some stage a perpendicular height. We can't use some sort of slopey height there. So it's base times height, but it's got to be a perpendicular height to the base. Area of a rhombus, we have area equals half x times y. So on a rhombus, which is a bashed up square, we have to carefully get an idea of the diagonals. So we have one diagonal length there hopefully known to us and another diagonal length there hopefully known to us. So it's a half of one diagonal length multiplied by the other diagonal length. Trapezium, half the height, a plus b. Now I've included the diagram there. The a and the b are the two lengths of the parallel sides, and the height once again has to be perpendicular to the base. So we type all that in or substitute those values into our formula there, and we get the area of a trapezium. Area of a circle, pi r squared. You'll remember that with a circle we have a radius, which is the distance from the center to the edge, and that's where our r comes from. Pi r squared. Find the surface area of a rectangular prism. If you have a think about it, we've got length times breadth times height. That would be volume. But for surface area, we've got an end shape there, which is a b times h. And we've got two of them because we have two identical size areas on either end there. That front face we could talk about here is length times height, which is there, and there's two of them on the front face and the back wall, if you think about it. And the floor is length times breadth, and so is the roof. And so there's two of those as well. So we could take the 2 out of each of those and sort of factorize it out the front there if we wanted to. That's the basic surface area arrangement for a rectangular prism. Surface area of a cube. Well, if you think about it, a cube is made up of a bunch of squares all put together really, and so if we have one side length, that's all we need here, and each of the this front face, for example, would be found by x times x, or x squared, to find the area of the front face, and there are 6 identical versions of that. So that's why we've got a 6 out the front of x squared. That's how that works for a cube. Surface area of a cylinder, we've got 2 pi r squared and 2 pi r h. Now you might remember from your studies here that a cylinder is made up of, if you're talking about the surface of the cylinder, talking about 2 squares. So that's where the 2 lots of the pi r squared came from. And the flat surface that we could spread out, if we split that and laid down flat, oh dear, got a bit wobbly there. The flat surface around the curved bit of it, our top would be equivalent to the circumference of that circle. If we split that and laid it out, our circumference here, our circumference formula is 2 pi r, and the area of this rectangle should include multiply by h as well. So that's where our 2 pi r h came from. So if you're thinking of that, all the little pieces of a cylinder, you could piece together that surface area formula, or just remember it. Surface area of a sphere is 4 times pi r squared. I'm fascinated by the fact that it's so similar to the normal area of a circle, but I guess you could think of a sphere and a circle being pretty similar to each other. And surface area of a cone, we've got pi r squared, which takes into account the circular base of the cone, and pi rl. Now this is probably the only time in geometry here, when you're doing area calculations, that you actually use a slopey height. That's the length of the distance between the point and the edge of the circle down there, that L bit. That's quite an interesting that we use it on this shape and this shape alone, really. So pi r squared plus pi rl for the surface area of a cone. So just running through a few areas there just to remind us, and a few features that you might have forgotten. So I hope that revision helps. peterblakemaths.com